Hello, greetings. Welcome to this lesson about motion in one dimension. I trust that you have your pen, your pencil, something to write with, and calculate as well. And as you can see on the board, we have our scenario here, and there are two questions that we are going to, talk about and obviously answer, in relation to the scenario. So let's go for it. Let's read the question here at the top. It says a taxi is traveling at a speed of 25 meters per second when a traffic light 40 meters ahead changes to red. The driver takes 1 second to react before he slams on the brakes. The taxi then stops within 2 seconds. Okay, so there's always keywords, important information, and important numbers when you read a question, and it's important for you to highlight it. Okay, so this taxi is traveling at a speed of 25 meters per second, meaning that in 1 second it will travel 25 meters, another second 25 meters. Okay, so in 2 seconds it will travel a total distance of 50 meters, for instance. Okay, so it's very important to be able to interpret the meaning of the SI units that are used in physical sciences. Okay, so that is the first important number that we see, or quantity. Okay, so speed of 25 meters per second when a traffic light 40 meters ahead. Okay, so the text is here, the traffic light is 40 meters ahead. If you cannot visualize the scenario, you can sketch it on your paper or, in your answer booklet when you attempt a question, which is, advised that you do it like that because it does simplify your understanding of the question. Okay, so this traffic light is 40 meters ahead, it changes to red. Okay, the driver takes 1 second to react before he slams on the brakes. So the reaction time for the driver is 1 second in this case. And in this reaction time, the taxi is still traveling at 25 meters per second. He is reacting, he is not slamming on the brakes or pressing down on the brakes yet. Okay, so it takes 1 second for him to do that. So then the taxi then stops within what? 2 seconds. Okay, so this is called your reaction time. I'll use RT to abbreviate reaction time, and this is called the stopping time. Okay, so the combination of this will give you the total amount of time it took for this taxi to come to a stop. Okay, so let's go to the question. I believe that you are clear in our understanding of the scenario and what is happening here. All right, remember you can always pause, you can always rewind and go back and just, listen to the lesson again. All right, so let's go to the first question here. Calculate the distance covered by the taxi during the reaction time. And remember, when we talk about motion in one dimension, we have 4 equations of motion that we can use, anytime that we talk about this type of situations in physical sciences. And obviously you want to list what you have and what you want. What do we want? Calculate distance. Okay, and in equations of motion, distance is denoted by changing x, meaning that obviously in your horizontal axis, like in your x and y, Cartesian plane in mathematics, you're looking for that distance covered by the taxi. What do we have? We have the initial velocity, 25 meters per second. Okay, but what are we talking about? We're talking about the reaction time. So it takes 1 second, for the driver to react before slamming the brakes. So in this 1 second, the taxi is traveling at what? 25 meters per second. So even the final velocity just before he slams on the brakes, it will still be 25 meters per second. Yes, and the reaction time, the RT here is given as 1 second. Okay, So we go to our formula sheet or our list of equations that we have and use the best one that will help us find the value for this quantity here, distance traveled by the taxi. So it is this one, VI plus VF over 2 times change in t. Okay, in some literature they don't use that multiplication sign. It is just denoted as times, time like that, which is fine, okay, because anyways bracket with an outer term means, the operation is multiplication there. Good stuff. So what do we have? We have VI, VF, okay, and then we have our change in time. 1, 2, 3 quantities. Yes, we have them. We just need this one. So this is the best equation that we can use in this situation. So we have 25 plus 25 over 2 times, what is the reaction time? 1 second. And this gives you 50 divided by 2 is 25. And 25 times 1 will be just 25. What are the SI units for distance? In meters. Okay, so this is the solution for this question here. So how do we interpret, the answer? Remember, inquiry means you must understand the meaning of your answer and find out how does it relate to the original scenario. So the taxi covers 25 meters in 1 second, and we bear in mind that the traffic light is 40 meters away. Okay, so the reaction time is 1 second, and in that 1 second it covers 25 meters, which makes sense to the given quantity here of the speed, 25 meters per second. Okay, good stuff. We're done here. B, calculate the stopping distance of the taxi. What is our stopping time? 2 seconds. Okay, so here our stopping time is 2 seconds. Okay, so again we are looking for distance, change in x. All right, and we have VI, which is 25 meters per second. Now, when the taxi comes to a stop, what will be the final velocity? You're right, 0, right, meters per second. So VF is 0 meters per second. Okay, so you have your quantities here and you understand what it is that you're looking for. So which one will be the best equation out of the 4? Okay, again, I chose this one, all right? So let's use it again. Change in x is equal to VI plus VF over 2 times change in time, okay? So what you just do now is substitution, okay? What is VI? We have 25 meters per second plus 0 over 2, right? And then we multiply this by what? By 2, okay? And then look at this. What do we get? 2 cancels, 2's cancels, and you have 25 meters as well, okay? Now let us inquire. What does this answer mean? It takes 25 meters for the driver to react, okay? So if we take away 25 here, he's left with what? 15, right, good. Now, he stops within 2 seconds, but in these 2 seconds, as it makes sense to the quantity given here for speed, he covers a distance of what? 25 meters, because obviously it doesn't maintain the velocity here. It comes to a stop, it's 0. So it's 25 plus 25, it's 50 meters covered from reaction time to stopping time, reaction distance to stopping distance. Now the follow-up question becomes, will the taxi be able to stop at the traffic light? Okay, definitely mathematically no, because 50 meters is greater than 40 meters. Yes, so that is very important when you do physical sciences grade 10s. It's very important that don't just answer and move on. Understand what these numbers mean in relation to the scenario and how the follow-up question also relates to the previous question. Yes, and the original scenario. Okay, so what are you given? What do you want? What does your answer mean? Those are the important inquiry questions that you need to ask yourself, when you enjoy science questions. Okay, so this is it. And I trust that, it simplifies understanding of, this type of questions. And yeah, you'll do more of this at your own, convenient time. And I thank you for tuning in. Remember to subscribe, remember to like the videos, remember to tell your friends and your classmates and your schoolmates, to tune in as well and enjoy learning. All right. Thank you so much. See you next time. Sharp, sharp.